we defined something called the conditional probability, and written like this: probability A vertical bar B, and that vertical bar means given. And that's the probability that the event A occurs given that the event B has already occurred. So we know some more information before we consider the probability of A, and it could affect the probability of that event. So the conditional probability of A given B is defined to be the probability of A and B divided by the probability of B. So notice that your given event is in the denominator. Now, if the outcomes in the two events are equally likely, so if you have equally likely sample space, then you can just use the number in A and B divided by the number in B. So that's so our second formula there, that is this equality, only holds for equally likely sample spaces. So let's look at an example here to get an idea. You roll a single die, and fair die, it's always going to be fair die unless we say otherwise. Let A be the event that you roll an even number, and then B is the event that you roll a number less than 3. So this is the same events that we had in the previous example. What is probability of A given B? So, well, by our formula here, probability of A given B, since this is a equally likely sample space, we can use the numbers instead of the raw probability. So number in A and B divide by the number in B. Okay, so B is the event that the roll is less than 3. There are only 2 outcomes in B, right? B is just 1 and 2. And then A is an even number, so that's 2, 4, 6. And then A and B, the overlap, is just the number 2, right? 2 is the only thing in both sets. So the given condition determines your denominator. So the number in B, there are 2 outcomes in B. And the number in A intersect B, there's only 1 outcome in A intersect B. So 1 divided by 2, 1/2. Try this one. What would be the probability of B given A? So we switch places. Is it the same or not? Pause the video for just a second and try that one. So with B given A, this will be the number, B and A have just switched places in the formula here. So this will be the number in B and A. And then the denominator is determined by the given. So this will be divided by the number in A. Well, the number in B and A is the same as the number in A and B. That's still 1. But now the number in A, there are 3 outcomes in A. So this is 1 out of 3. So notice that these two guys are not equal to each other. So if you switch the order with conditional probability, it's almost never the same probability.